Alright, welcome back to the video, guys. So this time we're going to be covering power. So power, based on the equation that we have written here, is work over time. So power is essentially dependent on the work that is being done, which we covered in the previous video. So power is measured in watts, which are equivalent to joules per second, since we know previously that work is measured in joules, or also known as a Newton meter. So because power, based on this equation, is dependent on work being done, if we have a situation where no work is being done, there's going to be no power generated. So take this example, which is similar to the man pushing on the wall in our last video on work. So he's again pushing on a wall, and because the wall is not moving, because we know that work is force times displacement, we therefore have no work that's being done. Despite the fact that he's applying a large force on the wall's not moving. So if we have no work that's being done, we don't have any power, despite the fact that he's applying a force. So now we're going to try a practice problem that's going to involve a very specific implication of power. So a man pushes a block with 50 newtons of force traveling at 10 meters per second. How much power is generating? So when you look at this initially, you think, okay, we have a time, 10 meters per second, kind of a time, it's a velocity, it includes time. And we have a force. Well, work over time, how does that fit in? So that leads us to an important implication of power. So if we know power is work over time, well, we said previously that work is force times a distance, or a displacement. So we know that power is essentially force times the displacement over time. So displacement over time, well, that sounds a lot like velocity. It's velocity. So we know that power is essentially a force times a velocity. So with this in mind, let's look back at this practice problem. Well, we know the force, 50 newtons, and we know the velocity they're traveling at, 10 meters per second. So we can now find the power that is being generated by multiplying 50 newtons times 10 meters per second. And we get a power of 500 watts. So that's the basics of power, and it's important to understand that because power is dependent on work, again, if you have no work, you have no power, and it's also important to understand that power can not only be represented as work over time, but also as force times a velocity.